Oh no. Harry's Pub, convenient and good. All right, so hello again, everybody. This is my first conference presentation ever, and I'm proud that it's at Shmoocon because I really love Shmoocon. At the same time, I'm kind of wary of the fact that this is the first Shmoocon with a Shmooball launcher contest, so I don't know. I tried really hard to make my slides good, but oh well. Anyway, so my name is Dan, and this presentation is going to have to be a little bit quick because I thought I was going to have like a longer slot, like a 40-minute, 60-minute slot, and now I have a 20-minute slot, so this is going to be somewhat akin to a ShamWow commercial a little bit. So let's just dive right into it. One thing I'd like to mention, since we're going through quick, no questions. If you want to ask me questions, give me comments, suggestions, money, lacy undergarments, you can see me at the core security booth after the talk, and I'll be around the con. So. Just a quick disclaimer about this. All the techniques that I'm using here are demonstrated on web-based technologies, web servers and things like that, but they apply to more than just that. Anything that takes a file name and processes it from user input on a Windows system has a possibility of being affected by this stuff. So just keep that in mind. Also, if you figure out a way to use these techniques that isn't covered in my presentation, you win a bottle of beer. Come by the core security booth. Also, there's haiku on every slide. Read it if you get bored with the slides. So the big problem here is that applications tend to do string-based comparison of file paths and file names rather than actually checking the file system. The problem with this is that we can reference one file with a bunch of different names, and that's why Windows File Pseudonyms, so fake names. And any applications might not expect some of these strings because, well, I guess you'll see soon enough. Some of these are based on undocumented features, some of it's just weird stuff, and some of it's, you know, coming back to what usually bites Windows in the ass in terms of security is backwards compatibility. So let's start out with that. 8.3 aliases. Now, what I mean by 8.3 aliases starts with the 8.3 format, which is 8 characters, a period, and then 3 characters for a file extension. And that's the DOS file name format. It has to match up to that. In modern Windows systems, if a file is created that does not match this format, an alternate name is also stored that can refer to the same file. Now, highly simplified, because for time reasons again, basically, you take the first 6 characters of the file name, add a tilde, add a digit to distinguish it from its other brethren, which share the first same 6 characters, and then throw on the first 3 characters of the original file extension. And that's an important part. We'll talk about that in a sec. So why do you care? Because let's say your IDS is looking for the old PHP-BB remote command execution in highlight.php, and it's looking for highlight.php specifically as a part of what's bad. But it's on the network, and we're not expecting it to actually go and check the file system of what it's supposed to be protecting, so we use the 8.3 alias for it. Goes right by. Maybe. Maybe haven't confirmed this on any particular thing, but also certain files that you might be restricting, maybe you're doing string-based comparison on it. The 8.3 alias isn't going to match it, and we'll see that later. Absolutely. And also, file type can be is often determined by the user input. So in addition to doing string-based comparison, we're also trusting the user input to give us the file extension. And normally that seems like a safe assumption, but when we're truncating the file extension and, you know, in this alternate name, not so good anymore. And more than that, this slide is a little complicated. I'm going to skip over a lot of this, but basically, in short, The set of long file names possible on Windows systems is a number which doesn't fit readily on a slide. So it's in scientific notation here. And the short file, the set of short file names possible is much, much, much smaller. And when we know the file extension, the number of possible 8.3 compatible names, which every file, by default on a Windows system, can be referred to with an 8.3 name, we have about 110 quadrillion possibilities, which for a computer isn't too bad. So brute forcing becomes a lot easier if we're trying to enumerate file names that we don't know. Next thing I want to talk about is characters which, when put at the end of file names, are just silently discarded, just gone. If any of you have read Team Ush.it's PHP file system attack vectors paper, great paper by the way, highly recommended, they talk about some of this stuff. So in Windows API calls, periods and spaces at the end of file names, completely gone. Just throw them out the window. And in the Windows shell, there's a whole bunch of other stuff that's discarded as well. Double quotes, and these are all in certain conditions. Double quotes, angle brackets. If you have current directory markers, the // or /dot or whatever you have, or if you have some directory and a double dot, these are all just silently ignored. I mean, some of these it makes sense, and some of these not quite so much. So all of these names, file.txt with a bunch of spaces, periods, double quotes, angle brackets, whatever, all of these refer to the same exact file. Now, if you look at that and think about, well, how am I going to write a regular expression for this? You kind of want to kill yourself a little bit. So that said, let's move on. But the different technique but similar use. We're still breaking string-based comparison here. Now, DOS special device files, you guys might be like, well, I know what those are, but so basically, they're similar to what you find in the /dev/namespace under your Unix, in a Unix file system, and they allow file operations to be performed on devices. But they have names like con and null and prn. And like I said, you probably already know about this, but here's some things that you probably didn't know. First, they exist everywhere. Everywhere. If you give a full path to anything and it ends with con, it's still going to refer to the console. Doesn't matter if you have access to the directory. As long as your path to con resolves all the way up to the point where you do a /con, even if it's a file, you can use that as a sort of directory, and it's still valid. It'll still refer to the console. So that's interesting. They can have any file extension you want. It's completely ignored. So con is the same as con.bat, .php, .conf. This is a long and arbitrary file extension, and some of you, I'm sure, are reading the last one there and thinking, wait, a long string of uppercase A's. Where do I know that from? So, but you're exactly right, a buffer overflow. If any of you have your laptops open, which I mean a Shmoocon, I'm sure some of you do, and you're running Windows, well, that's less likely, but go to the command prompt and type type space con dot and just throw a bunch of A's on there and see what happens. So in this scenario, a Windows application takes in a file name and verifies that it exists. Now, DOS special device files, they exist technically, and they exist everywhere. Great. And but they don't exist on the NTFS file system. But the program will probably assume that it does. So it probably assumes that it follows NTFS file system limitations, like maximum file name size. So I'm sure you know where I'm going with this. Now, we can also control, like I mentioned before, we can control how these, the device files are handled. So imagine that you have a web server running on some machine that also has a serial modem attached to it, or a Bluetooth dongle, which tends to use the COM ports. And you can communicate with that. So you request com1.php and then start sending data to that serial port. What do you think happens? Anybody? Whoop, that was not what I wanted to do. Okay, so next thing I want to